I received a couple questions about this, so I just decided to go ahead and make a little extra video to discuss this. So we're going to look at increasing and decreasing functions. And so this is a pretty formal definition here, but basically what we're looking for is we're looking for the domain of a graph for where it's increasing, decreasing, or constant. And we're going to read our graphs from left to right. So I'm not going to go through all these formal definitions. I think it's just easier to kind of show you in some examples. So as I was kind of saying, when we're determining whether a function is increasing, decreasing, or constant during a particular interval, focus on the behavior of y, and we're always going to read it from left to right. So the y is going to tell you whether it's going to be increasing, decreasing, or constant, and the x is how you give your answer. You're going to give your answer in terms of the domain of that interval. Now, on these intervals, we're always going to use parentheses, okay? And the reason why, we'll go ahead and look at problem number one. I'll kind of explain why we're going to do that. So coming down here, we're going to look at this graph on number one, and we're going to list the interval for increasing, decreasing, and constant. So we're always going to read it from left to right. And so as I'm coming, as I'm coming from left to right here, you can see that the graph it's going down. So the y values are decreasing, right? So the y values are decreasing from left to right here. And so that interval would be from negative infinity to -1. Now we're going to use a parentheses right there because at -1, basically that's kind of a neutral point because that's where it stops decreasing and then it's actually going to start increasing. So it starts to increase after -1. So then we're going to increase from -1 to infinity. So that's what's going on. So it's going up, sure, it's going up, it's increasing, but it's also going to the right to infinity. And then over here, when it was coming down, it was coming from negative infinity over here. Okay, there is no constant interval on this particular one. Okay, I'm going to go ahead and skip number 3 and go on to some of the more challenging ones. Let's see. Let's take a look at these two. Okay, so on number 9, you're actually going to have multiple intervals of it increasing. So if you look right here, this part is increasing because it's going up, and it's also increasing right here because it's going up. So these two increasing intervals. So this first one, it's increasing and it's coming from the negative infinity. Remember, we're going to describe it as the domain interval of where it's increasing. So it's increasing from negative infinity. It looks like it stops increasing at there at 0. And once again, we're just always going to use parentheses. Then I'm going to put a comma, and there's another increasing interval, and it looks like that begins at like 1.5, and then it ends at 3. It stops increasing at 3. Now, our decreasing intervals are going to be the other two we see right here. And once again, you want to go from left to right. So you want to list this one first from 0 to 1.5. So from 0 to 1.5, we're decreasing. And then also from 3 to infinity. So from 3 to infinity, we're also decreasing. Once again, this one didn't have any constant. Okay, so now we'll take a look at 11. Okay, so looking at 11, now this one throws people off a little bit right here, the increasing, because they think, oh, it's increasing here and then it's increasing here. That's all one interval actually, because I know there's a point right there that they emphasize, but that just, if you look, it's increasing and then it just starts to increase faster. So there's not really any point where it stops increasing. So your increasing interval is actually going to be from -2 all the way to 4. Okay. Um, there is no decreasing interval as you read it from left to right, but we do have two constant intervals. And so you can see there's one right here from negative infinity to -2. and then we have one from 4 to positive infinity. All right, here we go. All right, so from negative infinity to -2. And once again, I use a parentheses because it's a neutral point because it starts to increase. So is it increasing? Is it constant? So we just use a parentheses to indicate that it's approaching but not included. And then our other interval is going to be from 4 to infinity. Okay, so that's increasing, decreasing, and constant. Now, the relative maximums and relative minimums also, they're sometimes referred to as local. Sometimes you'll see the word local instead of relative, okay? And basically all that means is you're looking for little high points or low points in the graph, and so you're looking like at a little subsection of the graph. Because if you look at this example right here, it actually doesn't have a max or min because, see, it goes up indefinitely and it goes down indefinitely. So there is no top, there is no bottom. It goes up forever, it goes down forever. But in the middle, there's little sections where there's a low point or a section where there's a high point. And so that's all you're looking for is a high point or a low point. That's all you're doing. So don't overthink it. So looking at number 13, it has two little sub low points. So you just kind of look for little dips in the graph. That's what I kind of say. If you're looking for a relative minimum, look for like a little dip in the graph. If you're looking for a local maximum, look for a bump. So you can see we have a little bump right here. And so on your homework, the way it's probably going to ask you to do this is it's going to ask you, where's the relative maxima? Okay, the relative maximum is right here. And so what they're going to do is the relative maximum is actually the y value. So it's 4, and it's occurring, oops, write that a little bit neater. It's occurring at x equals 0. Okay, so a lot of times they're going to ask you, what is it, and it's referring to the y value, and then where is it, then that's the x value for that ordered pair. Okay, then you can see that we have two of the relative minimums. We have one here and one here, and so we have they're both occurring at 0. So 0, and one of them's occurring at x equals -3, and then we have 0 and it's occurring at x equals +3. So those are your two relative minimums there. Okay, now the last one, this last question, a lot of students have been asking about this last one. It's a good one because it basically encompasses everything in this unit thus far. It's got domain, range, intercepts, increasing, decreasing, our relative maxima, function notation. It's got a lot. It's got a lot of information. So if you can answer this question, you're in pretty good shape. All right, so we'll start with domain. Domain's actually pretty easy. If you look at this one, the domain is going to be your x values, right? And it goes left and right in both directions. So it's going to be from negative to positive infinity. There's no restrictions. It's going down, but it's also going to the left. It's negative infinity. It's going down, but it's also going to the right to positive infinity. So that's our domain. Now, range, on the other hand, range is going to be the y values. And so you always want to go from bottom to top. Well, there is no bottom. It goes down indefinitely. So there is no bottom. It goes down. So that's going to be negative infinity. But it does have a high point, and its high point is 4. And it kind of goes back down, goes back up a little bit, and then goes back down. But really, all you're doing is listing. For range, you list all the y values. For domain, you list all the x values. That's all you're doing. And so some of the y values occur more than once, and that's fine. So you can see the y value of 2 is occurring multiple times here. It occurs 3 different times, but you only need to list it one time in your range. That's all range is a collection of all the y values that occurred on the graph, and sometimes they occur multiple times, and that's fine. Okay, x-intercepts, that should be pretty simple. We should be familiar with that. That's just where we cross the x-axis. So we have two of them right there. You can use ordered pairs, or I believe on the homework you just do set notation. So -4 and +4. You want to use set notation. Don't put parentheses around it because then they're going to think that you're talking about an ordered pair on the graph, and we don't want to do that. Um, our y-intercept, so we have one right here at 1. And so once again, I'll use set notation, but if you wanted to, you could put it as an ordered pair, but I believe that they use set notation on the homework. Okay, intervals for which the f is increasing, for the function that it is increasing. And I see two intervals. I see the interval from here to here, and I see an interval from here to here where it's increasing, right? So it's increasing from negative infinity up to, looks like, -2, okay? And then we're also increasing from 0 to 3. Okay, now decreasing is going to be the other two intervals we haven't touched on yet, right here. So it's decreasing from -2 to 0 when x is -2 to when x is 0. The y is decreasing from left to right. So from -2 to 0. And then we're decreasing from 3 to infinity. Okay, part G throws students off a little bit here, but you don't want to overthink this. You just have to know your function notation. Basically, it's saying for which values of x, so they're asking for the domain, okay? What values of x for which f of x is less than or equal to 0. F of x is just a fancy way of saying y. So we're looking for when y is less than or equal to 0. And so if you look on the graph, here's your y-axis. So all the y values are positive here. They start to become negative right here, right below the x-axis. Now it says less than or equal to. So you get to include 0 as part of the criteria that you're looking for. So you're looking for any x values in which the y value is 0 or less than 0. So you can see right here the x-intercept. At the x-intercept, by definition, y is equal to 0. Right here at -4, y is equal to 0. And then you can see all these other points, the y value is negative, right? You can see that from the axis, right? Right here, okay? So all these points that I'm putting right here, they're all negative, and it continues indefinitely. It just keeps going down. And so um, that interval would be from negative infinity to -4. So from negative infinity, oops, here we go, from negative infinity to -4, um, those values right there, when x is anywhere between negative infinity and -4, the y value is going to be less than or equal to 0. All those points right there, y is less than or y is actually equal to 0 right there on the axis. And then you basically have the same exact thing here on the other side. So it starts right here, and y is 0. Now y is -1, -2, -3, -4, -5, and so on and so on and so on. And that continues from 4 to positive infinity. So that's going to be from 4 to positive infinity. Okay, so that all goes with part G. Okay, part I, what are the relative maximas? And so we actually have two of them here. So I'm going to kind of erase some of this stuff so we can see this. Okay. So you have, remember the relative maximas are just, you look for like little bumps in the graph. And so you have one right here in this little subsection right here. And you have another one right here in this little subsection right there. Those are your two little bumps in the graphs. And so let's see, you have a maximum of 4, and that occurs at x equals -2. And then we have another one at 2, and that occurs at x equals 3. All right. J shouldn't give you too much trouble as long as you know your function notation. So f of -2, all it's saying is what is the y value when x is -2. That's all function notation is. So when x is -2, the y value is 4. It happens just to be your one of your maximas, your relative maximas. So when x is -2, y is 4. Here we go. And then the last part of this is actually case is the values of x for which f of x equals 0. Once again, that's you just have to understand what f of x means. So they're just asking you when y equals 0, what is your x value? It's a very easy question, and it's actually the exact, that by definition, that's what an x-intercept is. By definition, uh, letting y equals 0 is the definition of an x-intercept. So the answer to this one is -4 and +4. At those two values of x, -4 and +4, the y value is equal to 0.